Hmm. And okay, one thing, ultimately everyone needs success. We need a brand, we need a good name, we need victory. How? Victory means on par what? Students or maybe the parents' intention also in future your kids need to be there in a good position. Obviously, as a learner need to be there in a good position. If you're a learner, you need to be there in a good position. Good position means what? Okay, maybe academic stage, you may got a admission in IIT or maybe CBIT or a normal engineering college. Past is past. Suppose if you're running BTech student. My experience, every IITN is not IITN, every normal college student is not normal college student. A lot of students I observed, IIT students, he got not even 6-7 lakhs package. Normal engineering college, like previously I told them, the uh, B grade colleges. He's from a B grade college. As a fresher, he got 15 lakhs, 20 lakhs also. Some students are there. A lot of projects are there. And to approach the companies, a number of ways are there. One is campus placements in normal college, there won't be that much support. And the reason the companies, okay, they are ready to come, but if they won't get the candidates, that is a headache for them, time waste. So through reference, reference definitely. Suppose myself, how I will give a reference to one student. When I got confident on that person, then only I can push his resume to the company. I don't want to kill the company time. Time savers required everywhere. That means reference, maybe relatives, maybe like me, maybe through internet based some examinations are there. Through internet, you can approach. Maybe some companies they open the gates for normal college students also. Through internet, maybe the first round, second round, third round, and after that fourth round onwards, invitation to the company directly. Next, come to the performance complex. Performance complexity means what? To understand this particular topic, generally basic maths is enough. School standard maths is enough. Leave about the programming language syntax. Don't try to take load. I'm going to C program. Don't take load in your mind about the C syntax. I'm talking about the logic. Now a simple task. Now the task. Now need a program. The program need to take responsibility to give all prime numbers between given two numbers. That means then when we run the program, need message, enter two numbers, something like this, enter two numbers, suppose 20 and 40, enter key. I need all prime numbers. First prime number 23, next 29, next 31, next 37, like this. This is the required result. This is the task. Okay, taken two variables, runtime given inputs. Next, the normal logic to check whether a number is prime means which is not with any number. Check start with 2 to the number. If it is not divisible, then you can confirm that it is prime, not divisible. Meanwhile, if it is divisible, no need to check with the next numbers. Immediately you can say that it is not a prime. Now 2 to up to the number. Checking. Go with screen. Go with the computer. Okay, now come to the screen. Going with the C++ compiler. Any programming language, any compiler, and C++ also we had different types of compilers. Any compiler is okay. I'm talking about logic, not the syntax, not about the compiler. Oh, in normal logic, to check a prime number uh, up to the number. Checking up to the number, check with 2, 3 like that. That is a logic developed. Open the source code. Okay, this is the program. Here at last number of lines is visibility is there. Total 30 lines code. Okay, I'm going to run this program. Message came, enter two numbers. Something like given 20, 40, enter key. Yes, everything is correct. Fine. Same program, same logic. I'm going to different syntax. Here programming you have concept, while loop concept. I'm going to different syntax to the for loop concept. Same logic. Here now the number of lines code is reduced, 23 lines only. Okay, run the program. Same message. Enter two numbers. Okay, 20, 50. I give it 20, 50. Yeah, fine. No doubt the result is correct. Okay, fine. Now I'm going with the big range. Check the time taking, how much time it is going to take to display the result. Observe the screen carefully. How much time it is going to take to display the result. Run the program. I'm giving big numbers. 1, 2, 3, 1100, 1000 and 1100. Here internal logic is check up to the number. That means for any prime number is occurred, check with 2, check with 3 like that. Internally the checking is going to be done up to the number. So for each prime number 1000 operations. After press enter key, hit observe the screen carefully how much time it is going to take to display the result. Enter key. Fraction of second immediately. Left side the serial number. First prime, second prime like that. The last one 16th prime. Alt enter. That means the font is increased. It became like window. Little font I increase. Once again run the same program. Enter two numbers. Same inputs I given within fraction of second. Now I'm going with some big range. Enter two numbers. Or normal screen is original screen. 1, 2, 3, 4, 5, 1 lakh, 1 lakh 200. For each prime number, 1 lakh arithmetic operations. So our Basel system may need some time. Enter key. Bit scrolled. Okay, anyway, less than 1 second time. Better at last go with the message. Printed. Okay, okay, okay. I'm increasing the font. I'm going with the big range. Font increased. Run the program. Enter two numbers. 1, 2, 3, 4, 5, 6, 7. 1 crore. 1, 2, 3, 4, 5, 6, 7. Back. 1, 2, 3, 4. 1, 2, 3. Now I given the input 1 crore, 1 crore, 1000. 1 crore, 1 crore, 1000. No doubt. For each prime number, obviously, internally 1 crore operations, right? For each prime number, internally 1 crore arithmetic operation. Check with 2, not visible. Prime number is occurred. That time. Check with 3, check with 4, like that. 1 CR. Obviously, no doubt. Here also some time, system needs some time. After press enter key hit, check whether it is taking any time here. Okay, I'm pressing enter key hit and parallelly stopwatch. Stopwatch. 1 crore, 1 crore, 1000. Stopwatch at a time, enter key and stopwatch start. I given 1000. Now 100 series started. 6th prime, 7th prime, slowly coming. It is taking some time. 12 seconds completed, 15 seconds, 300 series started. $400 series. I given 1 crore, 1 crore, 1,000. 600 series. Already 40 seconds completed. At last, okay, the message required. That time I will stop this. 700 series going on. 54 seconds completed. 800 series. 900 series. Okay, stop. See the time. 1 minute, 14 seconds. Okay. Now it taken 1 minute, 14 seconds time to give the result. Go with the board. Okay, just now we executed the prime numbers program. First 30 lines code, next space complexity reduced to 23 lines. Normally the basic awareness of C is enough to develop that program. Basic awareness in the sense, in my class, generally first 1 week, going to discuss the same application in the class after 6, 7 classes. Okay, now come to the performance. Check the performance. We develop the logic to check up to the number. So when I run, given inputs like this, 1, 2, 3, 4, 5, 6, 7, 1 crore, 1, 2, 3, 4, 5, 6, 7, 1 crore, 1,000 to get the result in this range. Total 1 minute, 14 seconds time. The program taken 1 minute, 14 seconds time. 1 minute, 14 seconds, nothing but 74 seconds time. Go with the big range. Same program, 1 crore, I'm increasing range 100 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 100 crore. 100 crore, 100 crore, 1,000. Same program, same logic. 100 times range is increased. So obviously more 100 times calculations. So obviously if you give input, the same program when we run, if you give input like this, 1 minute, 14 seconds into 100, that much time it required. That means 74 seconds into 100, 7,400 seconds time. That means totally more than 2 hours, nearly 2 hours. 1 hour, 3,600 seconds, nearly 2 hours time we need to wait to get the result. Same program. Obviously, system also needs some time. Nearly 2 hours time we need to wait. After give input like this, after the center key hit, 2 hours we need to wait. Much more big range. 1, 2, 3, 4, 5, 6, 7, 8, 9, 100 crore, 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. 100 crore, 1 lakh. Here 1,000. Here itself I increase the range 100 times. 1,000, 1 lakh. Once again 100 times I increase the range. So 2 hours into 100, nearly 200 hours. 200 hours time we need to wait. 200 hours means approximately minimum 1 week, nearly 8 days. 1 day, 24 hours. Almost 8 days we need to wait. Same program, if you run, when we run, if you do input like this, 100 CR, 100 CR and 1 lakh, after press enter key hit. After 1 week, come back and check the result. For each prime number, 1 billion operations. I given 1 billion and 1 billion, 1 lakh. 100 crore, 100 crore, 1 lakh. Generally 78% prime numbers. For each prime number, 1 billion 78% means nearly 5,000 to 8,000 prime numbers will be there. For each prime number, those many operations. So obviously this much time. Now increase the performance. We develop the logic. Okay, first logic up to the number. So the loop repeated for each prime number. Internally the process 1 billion times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 billion times. Total output 200 hours. The number of lines 30 lines code. Second, same logic up to the number, but the number of lines 23 lines code, space complexity, same thing only, same here 200 hours only. Next, increase the performance. To check whether a number is prime or not, check with 2, check with 3, not divisible, check with 4, like that. Here checking done up to the number. But is it required to check up to the number? No, right? Check number by 2, enough. That means off time. So 100 hours. Can we minimize more? Yes. Yes. Who can minimize more? Up to where checking is enough. Come to the logic. Say for example 101. Need to check whether it is prime or not. Normal logic. The first logic and second. Check with 2, 3, 4, like that. Checking done up to 100. 100 times arithmetic operations. No need. Number bit means up to 50. You can minimize more. Say for example 101. Actually 101 is prime. Check it out. Think logically. But check with 2, not eligible. 3, 4, not eligible. 5, no. 6, no. 7, no. 8, no. 9, no. 10, no. Stop. Immediately we can confirm it is prime. Think logically. Here right now the checking done up to 10. If it is required to continue the checking process, the next number is 11, 12, those things. Already 2, 3, 4, 5, 6 checking is completed. Kada. If you want to check with 11, 11 into 2, 11 into 3 is meaningless because 2, 3, 4, 5, 6 checking is completed. If you want to continue the checking process, 11 into 11, 11 into 12, like that, we need to check. What is 11 into 11? 121. That exceeded 101. Hello, are you getting my point? Right now, I want to check whether 101 is prime or not. Check with 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. I want to check with 11, 12, these all things. Immediately you can confirm it is prime. That means up to where checking is enough. Pause the video. Think. Up to square root of the number. 101 square root is 10 point something. So check up to 10. 289. We need to check up to 17. 17 square is 289. 289 is 289. It is divisible with 17. Prime number into prime number is not a prime. 23 into 23. It is not a prime, right? For that thing, we need to check up to 23. That means check up to square root of the number. That is enough. So modify the logic. Square root of the number. Square root of the number. Square root of 100 CR. Pause, think, and play. 10,000 and 10,000 is 10 CR. 20,000 20,000 is 40 CR. 30,000 30,000 is 90 CR. Some 33,000 change. It is 33,000. Just modify the logic like this. So only 33,000 arithmetic operations enough. According to the first logic, what I implemented, first and second, internally the arithmetic operations for each prime number, 1 billion operations. Just modify up to square root, only 33,000 times the arithmetic operations. Here 100 CR, where 100 CR, where 33,000. So how many times more times the performance is increased? 33,000 times. 33,000 into 33,000. This is 33,000 less number of times, right? So forget the result in this logic. 200 hours divided by 33,000. 200 hours, every hour 3,600 seconds, total seconds are placed there, divided by 33,000. Two zeros cancel, two zeros cancel. Here 33, here 36. Okay, maybe 1.2 something. Here 0 cancel. 20 into 1.2, maximum something. Okay, 25 seconds. Where 200 hours, where 25 seconds. If you didn't understand, once again replay the video. 200 seconds, 25 seconds time. Okay, now go with the system and check it out with this logic. Okay, come to the screen. Now I'm going with this, the fourth logic, directly square root. I'm using Zoom app to record this all. Wonderful app. I fell in love with it. Okay. Now go with the square root logic. Square root. Previous program here n t less than n up to n the checking done. Now here I'm checking up to square root only. Same 23 lines. Now I'm going to give input 100 CR. Wait. At last, better pull the message. Printf small letters. Something okay. At last, the message. Okay. Now run it. Enter two numbers. Now I'm giving input 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Back. 1, 2, 3, 4, 5, 6. 1, 5 zeros. 100 crore, 1 lakh I given input. According to the previous logic, what we executed, after press enter key hit up 1 minute time, we need to wait to get the result. 200 hours time. Now square root logic, enter key and here this one, stopwatch, start button at a time, enter key and start. How much time? I given 1 lakh. Now 12 or 13, 17,000, 18,000, 20,000 started. 30,000 series going on. 40,000 started. 50,000. 60,000 started going on. I given 1 lakh. 70,000 series started. Now 80,000. 90,000. Stop. See the time? 34 seconds. (34 seconds time. Next. Okay, here total we got in 34 seconds time. Actually here 25 seconds for printing some more additional time. Anyway, 34 seconds time. See, we are 200 hours where 34 seconds. Can we increase the performance more? Yes, obviously. Okay, now back. Same example, 101. Need to check whether 101 is prime or not. First check with 2. Not divisible. Next check with 3. Not divisible. Next check with 4. No. Already checking with 2 is completed. No? Checking with 4 is meaningless. So next check with 5. Next check with 6. No, already 3. 2, 3 checking is over. If anything, divisible with 6, automatically divisible with 2 also. So next check with 7. Next check with stop. Check with 8 meaningless. Already check with 2 is complete. Check with 9 meaningless. Already check with 3 is finished. Check with 10 already 2 square root is exceeded. Stop. That means to check 101 is prime or not. Check with 2, 3, 5, 7 like that. That means the perfect logic is check with all prime numbers less than square root of the number. Enough. That means check with 2, 3, 5, 7, 11, 13, 17 like that. Less than square root. So less than 33,000, how many prime numbers? Check with those things. Okay, we can check there. Less than 33,000, nearly 3,600. 10%. 3,600 prime numbers. Okay, check there itself. Already I checked. 3,600. Here, 33,000 times the process going to be done. Here only 3,600 times. So almost how many times more time the performance is going to be increased? 10 times. That means here 34 seconds. Here 3.4 seconds. Okay, go with the 5 seconds. Check it out. Now directly I'm going to run this the fifth one. But to develop the fifth logic, programming language need to know n number of concepts. Dynamic multiplication, arrays concept, pointers concept, or something. A number of concepts are there in the programming language. Need to use those all. Okay, come to screen and check. Now I'm going with the last logic, checking up to less than square root of the number. This is the program check less than square root of the number. Now the last logic, check with all prime numbers less than square root of the number. Number of lines, 65 lines. Okay, anyway, run. Enter two numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Back. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Enter key and stopwatch at a time. It is stopwatch enter key at a time. 67, 77, 87, 91. Stop. See there. 5 seconds time. This is called performance complexity. See the first logic 200 hours. Where 200 hours, where 500, where 5 seconds. We can develop the application like this, like this, like this, like this also. Assume that, okay, consider these two as only one. This is the second one, third one. This is the fourth one. 4 people are the developers. Everyone is developer. Everyone is there in the industry. Assume that 4 applications released globally. 4 programs available. Obviously, everyone is going to use which program? The last one. Just like WhatsApp, what we're using in our regular life, the chatting application. A number of companies, software companies are there in Hyderabad. A number of companies, they can develop applications similar to WhatsApp, but how to gain the performance here? To check the performance, when we attach the huge amount of data, share the photos or videos, then only we can observe the difference between another application and WhatsApp. Super WhatsApp. Okay. Fresher all these 4% people are recruited in industry. First person maybe the package 4 lakhs per annum. Second person, okay, 6 lakhs per annum, fresher. Third one, okay, very good, 15 lakhs per annum. The last one, high demand, 50 lakhs per annum. Learn